welcome to another edition of our online class. So we are still on continuation of a percentage error. Last class we stopped at example 3. Now we are starting from example 4. And this is the question. The question says a square is 10 centimeter by 10 centimeter. The student measured the side of the square as what? As 9.9 centimeter, and use it to calculate the area of the square. So we have to find the percentage error in the length and the area of that square. So how do we solve this solution? A percentage error in the length. We want to find the percentage error in the length. That's the first thing. So what was the actual length? The actual length is what? Is 10 centimeter. So actual length is what? Is actual length equals 10 centimeter. And the approximated length which the student measured is what? Is 9.9. Approximated length equals 9.9 centimeter, which means that the error in the length, so the error in that length is what? Error in the length equals actual length minus what? Minus approximated length. So actual length minus approximated length. Are you getting it now? So which means is equal to 10 minus 9.9, which is what? That's 0.1. Are you getting it now? 0.1 centimeter, right? 0.1 centimeter. So from there we can now say that the percentage error in the length will now be what? The percentage error in the length will be that error in the measurement of that length, which is 0.1 divided by what? Divided by the actual value, so which is 0.1 divided by 10 multiplied by 100. Are you getting it now? So when you do that, that should give you what? You know, that should be, this one will be this. You have 10 here, then 10 times 0.1. That should be 1%. So that is 1%. Then the second one, which is B, which says that we should find the error, percentage error in the calculated area of the square. So in the area of the square now, we have to find percentage error in the area of the square. Now, percentage error, right, in the area of the square. You know, square is what? Is equal to L times L, right? So definitely, which means the actual length, which is what? So the actual length is what? Is 10. If the actual length is 10, then actual area will be what? Actual area will be what? 10 times 10, which is 100, right? Which is 10 centimeter times 10 centimeter, and that should be 100 centimeter square as the actual area. Now the approximated value, which is 9.9. So approximated length approximated length equals what? 9.9 centimeter. So then definitely that is telling you that the approximated area will be what? Will be 9.8 times 9.8. So we have approximated area.
No.
Approximated area will now be 9.9 times 9.9 centimeter, which is what? 9.9 times 9.9 centimeter should give us 98.01 centimeter square, right? So from there now, error will now be what? The error will now be, so error in the square, in the area of the square will now be, the area of the square will now be what? Will now be that 100 centimeter square minus 98.1 centimeter square. 0.01, sorry, centimeter square, and that is what? So that will give us 1.99. So that should give us 1.99. 1.99, right? I think so. So 1.99, something you can find. So which means now the percentage error will now be, and you know that percentage error is equal to what? Error, which is the absolute value of that error, divided by actual. So which means this will now be error in the area over actual value multiplied by 100. So we know that we say that our error is 100 minus, let me check the value, 98.01, which gives us 1.99. It will now be 1.99 divided by, what is the actual value? That should be 100 centimeter square, right? And you know the actual area that we get is what? Is 100. So divided by 100. Are you getting it now? So multiply by 100, right? So this one cancel this. Now 1.99%. Please, the unit for percent error we always the percentage, because you know it's like putting this one, when you put this unit here and you put this unit here also, you know it will cancel, right? You know it will cancel, as the one we have been doing previous also. When you put unit, after you do your division, the unit will go. That's why I don't bother to put the unit there again. So which means that, so the value is 1.99%. So we can have one more example. Then after that, I can give you like 2 or so. I still have plenty of examples here, but let me quickly do this so that I can give you this one small practice question that you should go and try when you are free. When you are free. So example 5, right? Example 5. Example 5. Example 5. So we now move on to example 5. So we have example 5 here. So the question is the length of a running tank. The length of a running tank. The length of a running tank. Length of a running tank is measured and given as 400. Is measured and given as 400 meter. Is measured and given as 400 meter. You now say you should find the percentage error. Find the percentage error if the length is measured, A to the nearest meter, B to the nearest 10 meter, nearest 10 meter, right? To the nearest 10 meter. Then C to one significant figure. So let's move on. Solution now. Let me use this side now. Solution. Now, for the first one now, so we have B, so to the nearest one, to the nearest meter, right? And you know we have our this thing to be what? We have our actual value to be 400 meter, right? We have our actual value to be 400 meter. So which means that we now find the error of the measurement. Now from this question now we have 400 meter. Now see to the nearest 1 meter, right? Nearest meter also means nearest 1 meter. That's meaning of it. To the nearest meter simply means to the nearest 1 meter. So which means for this thing to be to the nearest meter, if they claim that this value is to the nearest meter, it means there will have been some value like 3 points, like something here like 9 point something. But the next thing now you find half of that one. Half of one is what? Half of that one is 0.5, right? So which means the error of the measurement will be what? Will be that plus or minus 0.5, which means to find the lower limit and the upper limit, you should have deducted this 0.5 from the 400. So if this is this, you now see the error. The error of the measurement is what? Is equal to plus or minus 0.5. So percentage error will now be what? Error of over what? Over that actual value multiplied by 100. So which is that's 0.5 multiplied by 400, right? Then that's 0.5 divided by 400 multiplied by 100. So this one here, so we have 0.5 over what? Over 4, which is 1 over 8, right? And that 1 over 8 also is the same thing as what? 0.125, if I'm right. You know this one should be, you know this one also over to, so it should be 0.125 if you check it. So we have 0.125%, and that's 0.125% times 0.1%. So you have 0.125%, so which is the same as 0.1%. So the next one, we set to the nearest 10 meter. To the nearest 10 meter. That's the next one. Now the half of 10 is what? Is 5. I am very sure that you should be able to do that one with the one we have been doing. So to the nearest 10 meter now. To the nearest 10 meter, right? To the nearest 10 meter. So which means that one will now be, we now say the error. So we now have to the nearest 10 meter, we now have the half of 10, half of that thing is what? 10 equals 5, right? Which means the error is what? The error is equal to plus or minus 5. Hope you get what I'm doing, because which means the limit will be something like this, right? 400 plus or minus 0.5. But we just don't need that one. So which means percentage error now will now be what? 0.5 divided by 400, I think so. Sorry, plus or minus 5. So will now be 5 divided by what? 400 multiplied by, so we now have 5 over 400 multiplied by what? 400. So when you divide this, we have 5 over 4, and that should be what? That should give us 1.25, right? So we have 1.25%. So which means the answer is 1.25%. So we have percentage error to be what? 1.25 is written as 1%. You know, the previous one is 0.1% and this one is 1%. If you can even guess the last one, which is to the nearest, which is to one significant figure, if you are good enough, you should know that the result will be something like, if that one is 0.1, this one is 1, that one should be something like 10%, I guess. So I think so. If you can guess very well. So C to the what? To one significant figure. So claiming this 400 to one significant figure, it means this is our one significant figure. It's equivalent to saying this 400. This thing is equivalent to saying 400 to what? Nearest 100. There is no difference between the two. There is no difference because the one significant figure falls on what? On nearest 100. So which means half of 100 is what? Half of 100 is half of 100 is 50, right? 50. So which means the error of measurement is what? Plus or minus 50. So you know the limit is like saying limit of accuracy is what? Is 400 plus or minus 50. So your percentage error will now be what? Will now be 50 over 400 multiplied by 100. So this one cancels this. We now have 50 over 4, right? So that's why I say it should be 10 point something. So when you see this, you should have 50 over 4. We now have 12.5. 50 over 1 is 12.5. So we now have 12.5 so percent. So 12.5%. So I think that is that. Because of our time, can I just give you one? Let me quickly give you this as an assignment. So you can do it. It's just one question. I have plenty of assignment to give you, but I still have some questions because the question on percentage error. I still have some questions that I want to do for you as an example. But just I'm rounding up for today. Just let me give you this. Go and do it. So just do this. The distance between a between two towns is 60 kilometers to the nearest kilometer. calculate the percentage error. So go and be practicing that one. So, and I think we are good to go for today. So we are going to recap.